and welcome to our video notes for solving systems of linear equations. If you are in the standalone version of this course, this is notes 1.10. If you are in the co-requisite version of this course, this is going to be notes 2.5. Okay. So, we've looked at graphing lines, we've looked at linear equations. This is going to be the intersection of those two topics. Definition: a system of equations is a group of equations involving the same variables where the equations are being considered together. The solution of a system of equations is the point or points that make both of those equations true. For this class, we are only going to consider linear equations. So here is an example of a linear equation. We have two equations. We have the equation y is equal to 3x plus 4, and we have the equation y is equal to negative 2x plus 2. And the goal here is to find the x and y values that satisfy both equations at the same time. Okay, since we're going to solve linear systems involving lines, there are three possibilities for the number of solutions. So we're going to talk about solving these systems by graphing. And so we know about graphing that we get lines. Now, if we're solving a system of equations, that's two equations, we're going to have two lines. So if we have two lines on the same coordinate plane that intersect at one location, so notice that this is one intersection. These two lines intersect at one point. This point is going to represent the solution to the system. Now, if we have two lines on the same coordinate plane, and these two lines happen to be parallel, we know that parallel lines have no intersection. Therefore, there is no solution. So two lines that are parallel have no intersection, therefore there's no solution. Now, on the third picture, it looks like we just have one line, but imagine, if you will, there's a second line that exists right on top of it. So what do we have? We actually have the same line. One line right on top of the other. So the same line means that we have infinitely many intersections. And if we have infinitely many intersections, we have infinitely many solutions. Alright, so of the three ways that we're going to talk about solving, graphing is going to be the first method that we look at. Then we'll talk about two other methods, substitution and elimination. So, let's talk about how to solve a system of equations by graphing. To solve a system of equations by graphing, we will graph the equations and find the point or points of intersection. That point is the solution to the system. So if you're going to solve by graphing, we're going to want to rewrite our equations in the slope-intercept form. Y is equal to mx plus b. And to keep everything in line and to make sense, not only am I going to call this line 1, I'm also going to use some different colors here. So let's use orange for line 2. Alright, so for line 1, we have 2x plus y is equal to 5. If we're going to get into slope-intercept form, we need to isolate y. So to do that, we need to subtract 2x on both sides, and that will give us y is equal to minus 2x plus 5. So from here, we can tell that b is equal to 5. That's our y-intercept. And m is equal to negative 2, which means we are going to go down 2 to the right 1. So let's just go ahead and graph line 1 on our coordinate plane. We'll start at 5, so that's going to be a point right here. And our slope says to go down 2 to the right 1. So down 2 to the right 1, and we'll just continue with that pattern, down 2 to the right 1. We can even go in the opposite direction of up 2 to the left 1. And we can draw a straight line through these points. Okay, and this is line 1. Now let's take a look at line 2. We have 2x minus y is equal to negative 1. We want to get y by itself. So let's start off by subtracting 2x on both sides. That gives us negative y is equal to negative 2x minus 1. But we have a problem. There's a negative in front of the y, so we need to multiply both sides of our equation by negative 1. And that will give us y is equal to a positive 2x plus 1. So this means that our y-intercept is at 1. Our slope is 2, which means we're going to go up 2 to the right 1. So we're going to start here at our point 1. And we're going to go up 2 to the right 1. We can even go in the opposite direction, down 2 to the left 1. We can draw a straight line through these points. And that's line 2. So here we have both equations graphed on the same coordinate plane. And we can see that they intersect at this point right here. And we can determine that the coordinates of that point are, or is, 1, 3. So this is our solution to the system. We're declaring that the point 1, 3 will satisfy both equations. Before we box this in, let's do a quick check. We're checking the point 1, 3, which means this is our x value and this is our y value. Let's look at line 1. So we have 2 times 1 plus 3. Does this equal 5? Does 2 plus 3 equal 5? Yes. So we know that the point 1, 3 satisfies equation 1. Let's take a look at equation 2. 2 times 1 minus 3, does that equal a negative 1? What is 2 minus 3? 2 minus 3 is a negative 1, equals negative 1, check. So it satisfies the second equation. This is the point that will satisfy both equations. So our solution is the point 1, 3. You could also say x equals 1, y equals 3. And that is how we solve a system of equations by graphing. So again, you're going to want to graph both lines on the same coordinate plane. You may have to do some work in order to get it into slope-intercept form. You can check your solution by plugging the values for x and y back into the original equations and verify that you get a true statement. And also remember that if you have parallel lines, we have no solution. And if your two lines end up being the same line, then we have infinitely many solutions.